Hello to everyone, whoever's watching on YouTube. So, since nobody has joined the session in person right now, so I'll wait for like 3-4 minutes before I start so that a few people may join the session. So, yeah, I'll start in 3-4 minutes. So, hi Priya, I'll start in like I'll start in 2 minutes. So maybe 2, 3 more people can join the session by then. So I'll start in 2, 3 minutes. Okay, so I guess no one else is joining the session. So I guess I'll start. So first of all, like hello everyone, like who was watching on YouTube also. So just to reintroduce myself, I'm Lakshay Saggi, the discrete maths TA for the Tuesday sessions, and this is sorry, this is I guess our sixth session for this course, and in this session we'll be discussing problems related to counting and stuff. So yeah, basically the contents based on the this week's lectures. So yeah, so I have some problems prepared, and I'll just share my screen and we can maybe start discussing the problems then. So yeah, let me just share my screen. Yeah, I hope my screen is visible. If it is not, or is there, if there is any problem with my like either audio or with my screen, you can let me know in chat if you feel there is any issue. If it's fine, then maybe we can proceed. Okay, I'll zoom it a bit, Priya. Okay, so I guess this should work, right? Okay, sure. Then I guess we can start with the questions. So I only have 5 questions planned for today, but I guess since this week's problems are on counting, so I guess each problem will require a bit of thought. That's why I kept it to just 5 questions. So yeah. So let's just start with the first question then. So first question is, an actor hosts a party where guests from 5 different states speaking 6 different mother tongues are invited. So generally in counting in generally if a lot of uh, if the problem statement is quite long, I generally prefer to uh, take out the main numerical abstract from it. So like this is a very long question, right? An actor hosts a party where guests from 5 different states. So I'll just maybe write down 5 states and 6 mother tongues. So the question says that an actor hosts a party where guests from 5 different states and speaking 6 different mother tongues are invited. Each guest can be only from one state and can have only one mother tongue. So there are a lot of guests in a party. Every guest has one state and only one mother tongue. And the state is one of these 5 states. The tongue is one of these 6 tongues. So two guests are comfortable with each other if they are from the same state and have the same mother tongue. So the guest will be comfortable when when like both of these things like they should be from the same state as well as they should have the same mother tongue, and only then will the guests be comfortable with each other. So now the problem statement is asking how many guests should the actor invite to ensure that at least 3 guests are comfortable with each other. And there's a note in the end that note that different people from the same state can speak different mother tongues. So yeah, I guess this note is something which is evident from here also. Like if there are 5 states and 6 mother tongues, how is this possible? This is only possible if someone from like 2 people, if some this is only possible if 2 people from same state speak different mother tongues, right? So yeah. So the problem is basically there are people invited. So every person has one state and one tongue, and the tongue has 6 choices. The state has 5 choices, and 2 people are comfortable only if they have same state as well as the same tongue. So yeah. So now we want to ensure that like how many guests should the actor invite to ensure that at least 3 guests are comfortable with each other. So now we want to ensure that at least 3 guests are comfortable with each other. So what does this mean? So there are at least 3 people, like 3 guests are comfortable with each other means that there are 3 people who have the same state as well as the same tongue. So I hope the question is clear. If the question is not clear, you can let me know via chat. Otherwise, I'll just proceed. So yeah, at any point, if you feel that you don't understand anything, then you can let me know via chat that there's some doubt, or you can yeah you can tell let me know via reactions also. So yeah. So there are 5 states. Let's just say the states are, I'll just call the states S1, S2, S3, and so on. So like S1, S2, S3. I'll just S1, S2, S3, S4, S5. And there are 6 different terms, right, mother tongues, which are, let's say, T1, T2, T3, T4, T5, T6, T6, T5, T4, T3, T2. So yeah, so there are these 5 states and there are these 6 terms. So what are the possible state comma mother? So every person we know, every guest we know will have uh, exactly one state and exactly one mother tongue, right? So how many types of guests are possible? Like what I'm trying to say is, let's just say we define type of a guest by via this pair. Like if a guest is of the type I comma j, if guest speaks the state, if guest is from the state si and speaks the tongue j. So I just mentioned, uh, let's define type of a guest. Type of a guest. So a guest is of type I comma j if the guest is from state si and has mother tongue tj, right? So uh, this I comma j just means that guest is from state si and has mother tongue tj. So how many types of guests are possible according to you? Uh, would you like to guess? Okay, so maybe I should maybe I should tell it since no one is typing in the chat. So yeah. So since there are like 5 choices for states and 6 choices for the guests, so this pair, the first value can have 5 choices and the second value can have 6 choices. Yeah, exactly, Shashi. So there will be 5 into 6, 30 choices. So number of possible types of guests will be equal to 5 times 6, because there are 5 choices for states and there are 6 choices for terms. So which is basically 30. So there can be 30 possible types of guests. So yeah, you're correct, Shashi. So yeah, there's these 6 possible choices for term. Correct. So the number of possible types of guests is equals to 30, as we have seen. So what does this mean? This means that 2 guests, and we also know that 2 guests are comfortable with each other if they are from the same state and have the same mother tongue. So two guests are comfortable. So if they have the same state and the same mother tongue, what I'm claiming is they also have the same type. I hope it's easy to see. Like basically, state comma mother tongue pair is essentially the type of the guest only, right? So if we want to see if two guests are comfortable with each other, we just need to see if two guests are of the same type. If they are the same type, then it will mean that those guests are comfortable with each other. So, so two guests are comfortable with each other if they are of the same type. So now basically what we need to, so the problem basically reduces to initially the problem was asking that we need to ensure that at least three guests are comfortable with each other. So now, so for three guests to be comfortable with each other, at least three guests to be comfortable with each other, or maybe like are comfortable with each other, then three guests are of the same type. So yeah. So if three guests are comfortable with each other, then we can say those guests are of the same type, right? So what we just need to ensure now to ensure that three guests are comfortable is just ensure that there exists a type which has at least three, uh, like there should exist at least three guests which have the same type. So we just need to find so we just need to invite people such that at least three guests have the same type, right? And uh, like I hope you guys must have read Pigeonhole Principle, and even if you have not read this by name, you must. Okay, so Priya is saying 30C3. Uh, how do you arrive at this 30 choose 3, Priya? That's a very big number. No? Like what I need to ensure is I just need to ensure like there is at least one type, like at least one type should have three guests. Maybe all other types need not have three guests also, but at least one type should have three guests. So like I don't think it would be 30C3. So maybe what I want to say is like suppose in the worst case, suppose I just invite 30 people. Like I'll just give you an intuition first of all. So suppose I just invite 30 people for now. So if I just invite 30 people, then can I say that there will exist like, or maybe let's just invite 60 people, not 30 people. Let's just invite 60 people. Like if I invite 60 people, 60, then can I say that there will be two guests which will have the same type? Or maybe let's just say like 31 people. Maybe this argument may seem a bit different at first, but I hope you guys must have covered it in lectures also, this sort of argument. let's just say I know there are 30 possible types, right? So what I'm claiming is if I just invite 31 guests instead of there are 30 types of guests, and now I am inviting 31 guests. So uh, can I claim that at least two guests will be comfortable with each other if I've just invited 31 guests? Yes. So Priya is saying, yeah, yes, we can say that 31. So how do we say this? We generally say this by pigeonhole principle, but it's just straightforward logic also, right? Because we can just prove this by contradiction also. Suppose I invited 31 guests. Maybe I should just write it down. Suppose we invite 31 guests. This implies that at least two guests will be comfortable with each other. And basically, why is this true? This is true because of pigeonhole principle. And if you don't know pigeonhole principle, then you can think of it in this manner that there are only 30 possible types, right? So, and if this is not true, that at least two guests are not comfortable with each other, it means that every guest must be of different type. So if every guest is of different type and there are only 30 possible types, then there can only be 30 possible guests at maximum. If no guests are comfortable with each other, then there can be maximum 30 possible guests. But we are inviting 31 guests. So that's why at least two guests will be comfortable with each other. So this is true because uh, if no two guests are comfortable with each other, then all are of different types. But there are only 30 possible types. So number of can't exceed 30, which is a contradiction here as we have invited 31 guests. So I hope this argument is clear. Like this is not the solution to this problem, but I'm just trying to build the solution. So if we want to be able to say at least two guests are comfortable with each other, then we'll need to, I'm claiming that we'll just need to invite 31 guests. And if we invite 31 guests, then we can always say at least two guests will be comfortable with each other. So I hope this is clear to everyone. So can we extend this sort of argument, the type of argument which I used here, to ensure at least three guests are comfortable with each other? So I did this for you guys for at least two guests. Can you do the case of at least three, like three guests of the same type? Can you do this yourself? Yeah. So Priya is writing in the chat that the answer is 61. So yeah, so you're correct, Priya. The answer will be 61. So similar logic will follow here also. By similar reasoning as above, if we invite 61 guests, at least three guests will be comfortable with each other. And why is this true? We can again prove this using this sort of argument. So let me just write this down again. Uh, like just changing the values, just copy paste this, and because if no three guests are comfortable with each other, then every type has at most two guests. So if no three guests are comfortable with each other, what it means is that every type will have at most two guests. Because if any type had three guests, then those three guests would have been comfortable with each other. So every type has at most two guests, but there are only 30 possible types. So number of guests can't exceed 30 times 2 because there are 30 types and two guests in each type. So total can't exceed 30 times 2. And so this will be a contradiction as we are inviting 61 guests. So yeah. So that's why if we invite 61 guests, at least three guests will be comfortable with each other. So correct answer is 61. So good job, Priya. Your answer was correct. I'll just underline this answer also. So I hope this is clear. So if anyone has any doubts in this, you can let me know via chat and I'll try to answer this. Otherwise, I'll be moving on to second question now. So, so second question is saying match the following. So it's written in form of a match the following. The question is written in the form of match the following, but it's essentially just a counting based question. Like we need to count the number of possible triplets in A part, number of possible triplets in B part and C part. And like, yeah, this is more of a counting based question. This is a counting based question and like just in form of a match the following. So I'll just look at each of these parts individually and try to calculate each of these individually. And yeah, we'll try to see if these, how do these matchings correlate with these. So yeah, so A part is, so basically we need to find the number of triplets I, J, K, where I and J are greater than equal to 0, but I and J are also less than K. So I hope you guys see the constraints. So we need to select triplets I, J, K such that K is the greatest of them all. There is a strict inequality here that K should be strictly greater than I and J. There is no relation between I and J here, like I and J can be anything in A part, but they should both be at least strictly less than K. And also they should be greater than equal to 0. So yeah, all the three numbers I, J, K will be greater than equal to 0 and I and J will be strictly less than K. This is what this constraint is saying. And also K should be between 1 and N. Right. So now we want to find number of such triplets. So any would anyone like to answer in chat? Like what will be the correct answer for this part? Okay, maybe I should explain it a little, and if you get the answer along the way, then maybe you can type in chat. So yeah. So let's just see how can we maybe count here. So note that the only constraint we need to ensure is like basically all should be non-negative because everything should be greater than equal to 0 and everything should also be less than equal to n. And besides that, the main constraint here is that this one that I and J should both be less than K. So, but they can also like, but they should be greater than equal to 0, but they should be less than k. So how can we maybe try this? So what I'm trying to claim here is that see, let's just see all the numbers from 0 to n plus 1. Okay, maybe I should explain it this way. So I'll divide my answer into two cases. So in A part, let's divide into two possible cases. So because right now, like I just know that I comma j is less than k, but I don't know if I is less than j or j is less than I, right? Or anything like that. So let's just divide it into those cases. Let's divide into two possible cases, which are basically I is equals to j, and like maybe I should mention cases in next line. So case one is, or maybe let's just say three possible cases. Three possible cases will be I is also less than j, and case two will be I is equal to j. Case three will be I is greater than j. So let's just resolve these three cases individually. And why I'm trying to break it into these sorts of cases, this is because like I knew this inequality between I, J, K, but I did not know the relation between I and J. So that's why uh, we needed to sort of break it into some cases so that we can count more easily. So what will happen here? So we know that I is less than J. So what this implies is, in this case, what it means is that if I is less than j and we know that 0 is greater than equal to I, so this means that 0 will be less than equal to I, which will be less than j, which will be less than k. Right. And now to count such cases, yeah. So yeah. So if I is less than j, this implies that 0 is less than equal to I, less than j is less than k. And this k is also less than equal to n, right? So now I want you to pay a bit attention. So basically now I know that all I, j, k are bounded between 0 and n, right? So I, j, k can only have values between 0 to n. And another thing which we know already is we also know that k should be greater than equal to 1. K can't be 0. But k can't be 0 constraint is already captured here because uh, this 0 this is a strict inequality sign, right? Not an equality. So k is anyways greater than something which is greater than equal to 0. So from here we can anyways say k is k will already be greater than equal to 1. So this constraint is sort of redundant, which says that 1 is less than equal to k because it is already captured here. So like here also we can just directly eliminate this constraint. From here also we see that 0 is less than equal to I comma j, which is strictly less than k. So from here we can say that k is strictly greater than 0. And since they are integers, if k is strictly greater than 0, then k is already greater than equal to 1. So this constraint of 1 is less than equal to k was sort of pointless. So yeah, or let's just say redundant. So we don't need to uh, take care of this 1 is less than equal to k case here because it's already implied by this inequality. Yeah. So now basically we have the numbers from 0 to n, and we need to choose three numbers I, j, and k such that their ordering is I is less than j is less than k, and they are strictly unequal, like they can't be equal. So what I'm claiming is this is just equal to this is just the number of ways to choose three elements to choose three numbers from 0 to n, both included. So we just need to choose three numbers from 0 to n. And we just need to choose three numbers from 0 to n. And I'm claiming that choosing these three numbers will be equivalent to finding out the number of ways of getting ijk such that 0 is less than equal to I is less than j is less than k is less than equal to n. And why is this the case? Because let's suppose I just select any three numbers. Like from 0 to n, I just select the three numbers. Let's just say 2, 5, and 7. I selected these three numbers. Or let's say 2, 7, and 5. If I select any three numbers, then there is exactly one way in which I can assign them to I, j, and k, right? Because suppose I select three numbers, 2, 7, and 5. Then I know that I should be the smallest one, j should be second smallest, and k should be the largest. So if I select three numbers of 2, 7, and 5, then I know that I should get the value of 2, the 5 should go to j, and 7 should go to k. Sorry. So you can sort of see that there is a one-to-one correspondence between like finding the number of possible triplets following this condition and just the number of ways to choose three numbers from 0 to n. Because anytime I choose three numbers between 0 and n, then there will exist a unique assignment of those numbers to I, j, and k. Because I, j, and k respect this inequality of I is less than j is less than k. So I hope I'm making a bit of sense here. So now we know that number of ways to choose three numbers from 0 to n is just n plus 1 choose 3, right? Like from 0 to n, if 0 and n both are included, so there will be n plus 1 numbers, right? So from n plus 1 numbers, we just need to choose three numbers. And so they can be chosen in like n plus 1 choose three ways. So which will be just equal to n plus 1 choose three. So yeah. So for this case, we obtain, at least for this case, that 0 is less than equal to I is less than j is less than k. Or maybe this case, like this was actually the case which I took, and this implied this thing. So for the case when I is less than j, I will get this n plus 1 choose 3. So by similar reasoning, if I take I greater than j, here also I'll get n plus 1 choose 3. So case 1 and case 3 are actually resolved. And so what remains is this case 2. So case 2 is I is equal to j. And so yeah, I'll just write it down then. So what happens here? So 0. So we initially know that 0 is less than equal to I comma j, which is less than k. So 0 is less than equal to I, which is equal to j, and which is less than k, and which is less than equal to n. Right. So in this case, so earlier note that we need to choose I as well as j as well as k in earlier cases. But here note that we have one lesser degree of freedom. And what do I mean by that? Like I can choose k to be something, but as soon as I choose one of these i's or j's, the other thing will become fixed because I is actually equal to j. So suppose I choose I equal to 5, then j will also be exactly equal to 5. So there, like I can't choose another j, right? So basically, if I is equal to j and this is less than k, here I won't be choosing three numbers actually. I'll just need to choose two numbers now. because if I choose two numbers, like I assign the number 7 to, let's say, k, and I assign the number 2 to I, then j will also become equal to 2 only. So what I'm claiming is, here I chose three numbers from 0 to n, both included. But here I only need to choose two numbers from 0 to n, because the third number, because, like, let's just say I choose two numbers, 7 and 5. Then I know that the larger value will go to k and smaller value will go to both I and j. So like if I choose the number 7 and 5, so k was larger, so k will have the value 7 and I and j will both get the value of 5. So there will be a one-to-one correspondence between choosing two numbers between 0 and n here. So I'll just copy this and just change the values. So this is just the number of ways to choose, not three, but instead two numbers from 0 to n. And how can you choose two numbers between 0 to n? It will be n plus 1, choose two ways. So I hope I'm making some sense here. So let's just see. I'll just bold all these numbers which we obtain. Right. So these are the only three possible cases, right? That I can be less than j, I can be equal to j, I can be greater than j. These are only three possible cases. And all these three cases are disjoint, right? Like no two cases can overlap, because if I is less than j, it cannot be equal to j. Similarly, if it is equal, it cannot be greater. So total number of ways will just be equal to, so total number of ways will just be equal to the sum of these three cases, since these are disjoint. Right. So total number of ways is equals to sum of all possible cases, as all cases are disjoint. So which is actually equal to n plus 1 choose 3 plus n plus 1 choose 2 plus n plus 1 choose 3 again. So this n plus 1 choose 3 and this n plus 1 choose 3 can be written together by multiplying a 2. Right? So 2 times n plus 1 choose 3 plus n plus 1 choose 2 will be my correct answer. So this will be the total number of ways for the option A, which is like this second row here. 2 times this C n plus 1 comma 3 means n plus 1 choose 3. So C of A comma B means A choose B. So this will be 2 times n plus 1 choose 3 plus n plus 1 choose 2. Just same as this. So yeah. So let's just go to B then, the B statement here. So again, I am just saying that if you guys have any doubts, then uh, you can ask me in chat. So number of triplets I, J, K, where so B option, B question says here that we need to find number of triplets I, J, K, where 0 is less than equal to I, is less than J, is less than K, and 1 is less than equal to K is less than equal to N. So can you guys answer this? I hope you guys should be able to answer this B part. Since we have already done A, I really think that B part can be done easily by a similar logic to A. So would anyone like to try it out or just make a guess? Okay, so I guess I should tell you. So the B part is just asking number of triplets ijk such that 0 is less than equal to I is less than j is less than k. And what I'm claiming is this part is something which we have already seen in here. Uh, I'm just claiming that this B part, number of triplets ijk, where 0 is less than equal to I is less than j is less than k, is just same as this only, right? Because in this case, we assume I is less than j, and what this arrived us and what this helped us arrive at was like this thing. 0 is less than equal to I is less than j is less than k is less than equal to n, which is the same thing which has been written here. So this we told that it can be done in n+1 choose 3 ways. So yeah, basically this B part is just the case one of A part. And this had the answer of n+1 choose 3. So B part will have the answer as n+1 choose 3 also. So yeah, Janvi has written n+1 choose 3. So yeah, that's the correct answer. Nice job, Janvi. N+1 choose 3. And what can we say here? Why is this the answer? Same as case 1 of A. So yeah, let's just come to C part then. So C part is number of triplets ijk, where 0 is less than equal to I is equal to j is less than k, and 1 is less than equal to k is less than equal to n. So again, uh, would anyone like to answer in chat? I'm just claiming this is also one of the cases of this. Like C part is also one of the cases of A part only. So something which we have already discussed, like which we discuss right now only. So I'm just saying that this part, like this case 2I equal to j part was actually this only, right? That 0 is less than equal to I, 0 is less than equal to I is equal to j is equal to j is less than k is less than k. And this k is already less than equal to n. So this case two of A part is essentially this C part. And we had already answered it to be n+1 choose 2. So yeah, C part has this answer of n+1 choose 2. So I'll just so same as case 2 of A part. So yeah, so I hope the second question is clear. So I'll just write down the correct answer in form of matching. Also, since we had to do the matching, correct answer is A will be matched with 2. This B will be matched with B had the answer n+1 choose 3, which is 1. And this C was uh, matched with n+1 choose 2, which is this C. So yeah, this is the correct answer. So, so if no one has any doubts, then I guess I can proceed to next question then. So next question is based on recursion. So maybe I should. Yeah. So let Tn be the number of ways of tiling a 2 cross n floor with infinite number of tiles, which are of size 1 cross 2, such that the entire floor is covered with tiles. Choose the correct expression for Tn. Among the following, note that the tiles can be fit on the floor as a 1 cross 2 tile or by rotating as a 2 cross 1 tile. So I'll try to explain. So basically, we are given a tile floor which has like 2 rows but n columns. And we are given a tile of, let's say, length 1 and width 2, but like it can be rotated also. So it can be made a 1 cross 2 tile, or it can also be just considered a 2 cross 1 tile. And we want to now tile our floor. So in how many ways can we tile the floor? We need to answer it in form of recursion. So just to give you guys an idea for this, I'll try to. So yeah. Hmm. So yeah. So let's just consider this. So the problem is essentially similar to this. Consider this table as a tile, right? Like as the floor. So here, this is my floor, which has 2 rows. So the floor is 2 cross n. So basically, there are these 2 rows, and here n equals to 5 as there are n columns. But consider this that these are actually n, like there are more columns in the end, which I have not shown. And now we want to tile this floor, and the tiles which can be used are of form 2 cross 1 or 1 cross 2 tiles. So a 1 cross 2 tile will look something like this, the part which I have highlighted, this blue portion, because the 1 cross 2 tile will be like having a length of 1 and a width of 2, right? Or I can also tile the floor using a tile like this, which has a length 2 and like width of 1. So these are the two possible ways in which I can place a tile. So I can place it like this, or I can place it like this. And now I want to actually uh, tile the whole floor. Entire floor is covered with tiles. So it can't be that suppose I only cover these. Suppose by some covering I only cover this part and I leave out this bottom part. It can't be done. I need to cover the whole floor. So I need to cover this part of the floor as well. So every cell of the floor should be covered by tiling. So this is the main part of the question. And now I need to find a recursive expression for this. So to do this, let's just think of it in this manner. So suppose I take the first tile. Uh, Maybe let me just write it down. Let's just consider the first tile to be placed, right? Consider the first tile to be placed. Or let's just say I'm placing the tile in the as early as possible, right? I'm placing the tile as early as possible, like in at least covering the first cell of the first column, right? So if the tile is placed in 2 cross 1 manner, like there are two cases, right? Let me just consider first tile to be placed. There are two ways in which the tile is placed. So what are the two cases? Case one is if the tile is placed in 2 cross 1 manner, right? So in this case, what will happen? Maybe I should just go to the next page with the whole question. So it becomes a bit easier for you guys to follow. So yeah. So case one is if the first tile was placed in a 2 cross 1 manner. In this, what will happen? Let me just show you. So I'll just copy this. So what I'm trying to say is the first tile was placed in 2 cross 1 manner. So these two were colored. So yeah, let's just say these cells were covered, right? So now this is the part of the floor which has remained uncovered, right? So this part of the floor has remained uncovered for now. But what can I say? So basically, first of all, I can say that since one column has been already covered, so now there are only n minus one columns of the floor left, right? So so basically, if Tn was the answer to a number of ways of covering these n tiles, then if I just place the first tile in 2 cross 1 manner, then the remaining tiles can be placed in T of n minus 1 ways. Maybe I should write it down properly. So for a 2 cross n floor, let the number of ways to tile the floor is equals to T of n. Okay, Priya, I'll get back to your answer. So Priya has written that the answer should be T of n equal to 2 times T of n minus 1. I'll just get back to it. I think it's not correct, but yeah, I hope it will be clear when I explain this. So yeah. So for a 2 cross n floor, we are given the floor area of 2 cross n. So let the number of ways to tile the floor be equals to T of n. I just defined some notation that T of n is equals to the number of ways for tiling a 2 cross n floor. So now in this case 1, where the tile I have placed is in a 2 cross 1 manner. So here it is easy to see that the remaining 2 cross n minus floor n minus 1 floor. So the floor now only has n minus 1 columns left. Can be tiled in T of n minus 1 ways. Right. So I'll just keep this bold. And just keep this notation also bold. So I see, so if I go with a 2 cross 1 tile, then I know that there will be T of n minus 1 ways to tile the floor then. Because the floor will be of size now 2 into n minus 1. And this can be tiled in T of n minus 1. Because 2 into n can be tiled in T of n. So 2 into n minus 1 will be in T of n minus 1. So now let's come to the second case. So case 2. So case 2 is if the tile is placed in 1 cross 2 manner. So now this is a trickier case. Why am I saying this? So this was my initial floor, and now the tile has been placed in 1 cross 2 manner. So, or maybe I should say, consider the tile which covers the first cell of the floor. Or let's say the top left part. So I'm just considering the tile which covers the top left part of the floor first. So this cell. So this part of the floor, whatever tile cover, I'm considering that tile. So if this tile was placed in this manner, like in a 2 cross 1 manner, then I know that there are T of n minus 1 ways to tile the floor, right? But if this tile which covers this part was placed in a 1 cross 2 manner, so actually this tile was present like this. I hope it is clear, like the part I'm highlighting. So the tile is covering this cell, but is placed in a 1 cross 2 manner. So it covers two columns. So the tile is actually like this. So I'll just color this also. Maybe I'll just pick some random color. So yeah. So Priya, I'll get back to your question. So Priya is asking, what if n is odd? So actually, Priya, if n is odd, then also you will be able to obtain some answers, right? Because even if n is odd, you can always cover it using at least these tiles, right? Using these 2 cross 1 tiles, because one tile covers whole column. So here, let's say n is odd. This is also n is equal to 5 in this table which I built, right? And in this table, I have at least one way, right? I can tile this, I can tile this, I can tile this, I can tile this, and I can tile this. So there are similarly a lot of ways. So like n of like when n is odd, it's not like a very different case than n is even. Because suppose I use the first tile like this, then the remaining untiled floor is anyways now for even n, right? Because now there are only 4 columns left. So 4 is even. So like an odd problem is like it's not like n is odd and n is even will make much of a difference. Yeah. So if we are using the tile in 1 cross 2 manner like this, then what I'm trying to say is this is only the first tile which we are used in 1 cross 2 manner. This is not the this is not how we are fully tiling. Like what I'm trying to say here is that these cells will also need to be tiled, right? We know that the whole floor needs to be tiled. So this floor can't be tiled using now this cell can't be tiled using a 2 cross 1 tile, right? Because this part is already tiled. So if we use a 2 cross 1 tile here, then these two cells should have been tiled. But this cell should is already tiled with this green tile. So the only way to cover this part of the floor is using another 1 cross 2 tile. So what I'm trying to say is if I use one of this 1 cross 2 tile, then I need another one of this tile to cover the bottom part of this. So we will need another 1 cross 2 tile to cover the cells immediately below the green tile. So below this green tile, the cells which are here, I need another 1 cross 2 tile to cover these cells. These cells cannot be covered in any other way. So I'll just copy this again. And these should be again covered using a 1 cross 2 tile. So maybe I'll just put some other color here. So it's clear that these are differently colored. So these parts of the floor are covered using 1 cross 2 tiles. And now we sort of see that these two columns are done now. These two columns are now fully tiled. So initially there were n columns. Two columns have been fully tiled. So only n minus 2 columns remain untiled. Right? So what I'm trying to say here is that only 2 cross n minus 2 floor remains untiled now. This can be tiled similar as we define to Tn to be two number of ways to tile a 2 cross n floor. So to tile a so this can be tiled in T of n minus 2 ways. So is this clear? So what I'm trying to say here is that basically if we used this 1 cross 2 tile here, then we'll need to strictly use 1 cross 2 tile here. And because of this, these two columns will be covered fully. And so we only need to cover the remaining 2 cross n-2 floor, which can be tiled in T of n-2 ways. And so since there are only these two possible cases that either a tile is in 2 cross 1 manner or 1 cross 2 manner. So, and these two cases are disjoint. So we get as case 1 and case 2 are disjoint, T of n, which is the total number of ways, will be nothing but T of n-1 plus T of n-2. So this is something which I'm claiming here. Because like this part was covered, this part took T of n-1 ways, and this part took T of n-2 ways. So the total number of ways is T of n is T of n-1 plus T of n-2. And as you see, like n being even or odd does not make much of a difference here. Like only the recursion mainly matters. N being even or odd does not matter. So is it clear to you, Priya? Why does n being odd or even does not matter? Or is there? Okay, so can you type your doubt basically? Like, what's the issue? Like, if n is odd, what's the issue? Yeah, okay, let's just consider n as 5. So this is n5, right? Because I have these 5 columns. So what's the issue with n being 5? Uh, okay, so we are saying consider n is 5, and if we take T of n-2, it will be repeated once. So basically, if we take T of n-2, then we'll just need to take T of 3, right? Like, so Priya is saying that if we take T of n, if we take n as 5, and if we take T of n-2, then it will be nothing but like it will be nothing but like T of 3, right? Then we'll need to calculate T of 3. So what do you mean by repeated once here? Okay, Janvi, I think you also have a doubt. That's why you have raised your hand. Maybe I'll just first clear Priya's doubt and then uh, I'll get to you. I'll get to your doubt. So Priya, would you like me to turn on your mic for some time so that you can ask your doubt on mic? Do you like? Okay. So just wait a second. I'll unmute you. Yeah, I believe you can use your mic now.
Yes, what I'm saying is if we are using 1/2 tile,
Yeah.
so 1/2 will be placed in first row and 2 columns. Huh?
Yeah, like
Then
you can see
that
my screen,
sequence
right?
would be repeated.
This is the green tile in which it will be
Yes,
placed, right?
yes. Now for the next sequence, I mean we are placing next 2 tiles just below it.
Yes.
Yeah. So this will be the case next, the diagram that is drawn.
Yeah.
Now for next two columns, again same sequence will be repeated.
No, no, no. For next two columns, for these three columns, basically we'll again have choices, right? So how did we define T of
Oh,
n?
earlier two. Okay, okay, earlier two. Okay, okay,
Yeah.
okay, okay.
So
Now it is clear.
here now
Yeah.
the cases will be like we can tile this using this manner also.
Yes, 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 yes,
Okay.
yes. Now it is clear. Yep.
Okay, okay. Okay then. So if it's clear then maybe Janvi, do you also have a doubt which you would Janvi, your hand is raised. If you have a doubt, do you want to type it out in chat or should I unmute you? Or is your hand raised just by mistake? Okay, so okay, so Janvi is not responding. So I'll just assume her hand was raised by mistake since she has lowered her hand. So yeah. So maybe now uh, let's go to then. So this is the recursion relation which will get that T of n equals to T of n minus 1 plus T of n minus 2. And what do we get from this? So this was the option like T of n is equals to T of n minus 1 plus T of n minus 2. So option A will be the correct answer here. So I'll just write it here since I don't want to waste another page. Okay. So yeah, I hope it's clear. So let's just come to question 4 then. Question 4 is pretty straightforward. If you guys have seen the lecture videos, then this is just a question of solving like recurrences. Like choose the correct solution to equation. So basically, like choose the correct solution is just fast. Like there are just a bunch of options, but what we essentially need to do is uh, maybe I'll just crop out the options also. Like no need for options in this question, anyways. We can just uh, have this question as a separate question itself. So, or maybe let's just keep it as it is. What's the issue? So yeah. So the equation given, recurrence equation given to us is a of n is equals to 2 of a n minus 1 plus 3a of a 3 times a n minus 2. Like 2a n minus 1 plus 3a n minus 2. And we are given that a0 is 1 and a1 is 5. And we just sort of need to find the correct solution. So fitting in the options is not the correct method. Like it's one of the ways to try, but that's not the correct way to approach these sorts of problems. So how do we solve these kinds of recurrences? It must have been discussed in the lectures also, but I'll just discuss the brief overview of it also. So we form a characteristic equation for the recurrence and then find the roots of that equation and try to plug in these values to find the actual solution to the equation. So maybe I'll just type out the whole solution. So to solve the recurrence, to solve the given recurrence relation, we first form the characteristic equation for the recurrence. Uh, to form the characteristic equation, just replace a of n by x square. So Note that if there are three types of terms like a of n minus 1, and a of n minus 2, then we'll replace n this a n by x square, a n minus 1 by x, and this a n minus 2 by 1. Similarly, if there was a n minus 3 term present also, there was some a n minus 3 term present also, then that a n minus 3 term should have been 1. A n minus 2 would have gotten x, a n minus 1 would have gotten x square, and a n would have gotten x cube. So it's like the lowest degree term, like the a n minus ith term will get the constant, will get the value of 1, and will give like the terms increasing in the terms increasing in order will give them like 1 x, x square, x cube, and so on. And a n will get the highest power of x. So something like that. So this must have been covered in the lectures also, but I'm just sort of uh, recalling it for you guys. So yeah. So we just replace an this an term by x square, this an minus 1 by x. An minus 1 by x and a of n minus 2 by 1. So the characteristic equation will become yeah. So characteristic equation here will be basically x square is equals to 2x, because an was replaced by x square, an minus 1 was replaced by x, and this an minus 2 was replaced by 3. So x square is equals to 2x plus 3 is the characteristic equation. So what are the roots of this equation? So we can easily see like it's a quadratic equation. So solving quadratic equation is not so hard. So I'll just uh, do this orally to find the roots, and or maybe it can be just seen easily using factorization also. So this becomes x square minus 2x minus 3 equals to 0. So what this essentially means is roots of this equation. So this is just like I'll just discuss this early. So x square minus 2x minus 3 equals to 0. So this can be written as x minus 3 times x plus 1 is equal to 0. So the roots will actually be 3 and minus 1. So you can verify it also that x equal to 3 will be a root for this. Like x square will be 9 and 2x will be 6 plus 3 9. Similarly, minus 1 will give me minus 1 squared 1. 2 times minus 1 will be minus 2 plus 3 will also give 1. So both sides will be 1. So roots of this equation are x1 equals to minus 3 and x2 equal to, okay, sorry, x1 equals to 3 and x2 equals to minus 1. Right. So these are the two roots. And now how do we proceed after obtaining the roots of the characteristic equation? Then we know that any solution to this recurrence. So the solution to the given recurrence will be of the form uh, some coefficient C1 times x1 raised to the power n. C1 x1 raised to the power n plus C2 times x2 raised to the power n. So this will be the any solution. So this will be the form of any solution for the given recurrence. So we know that x1 is equal to 3 and x2 equal to minus 1. So plugging in these values, uh, this will be nothing but a c1 raised to the c1 times 3 raised to the power n, because x1 was 3, and similarly c2 times minus 1 raised to the power n. So this will be the solution. So any solution to this recurrence equation. So note that any solution to this recurrence, like an equals 2an minus 1 plus 3n minus 2, will be of this form. And like actually, to determine the C1 and C2, what will be the C1 and C2, we'll use the given base conditions. So note that for different base conditions, we'll get different C1 and C2. So even though we get the same recurrence, we'll get different solutions if base conditions are different. And this sort of makes sense, right? So now, basically now we'll use these base cases. So first of all, we know that any solution will be of this form. And now we'll try to use base cases. Now we find values of C1 and C2 using the given base cases. And how do we do? So we are given that A0 is 1. So A0 is 1. This implies that putting in n equals to 0 in this expression should give me a value of 1. So this means that maybe I should just copy this and put n equals to 0 here. So 3 raised to power 0, C1 times 3 raised to power 0 plus C2 times minus 1 raised to the power 0 should actually give me 1. And so 3 raised to power 0 is actually 1 only, minus 1 raised to the power 0 is 1 only. So what this essentially means is that C1 plus C2 is equals to 1. So this is my first equation. Similarly, I'll obtain another equation by, I'll just copy this and change the values. We obtain second equation by saying A1 equals 5. So if A1 was equals to 5, then we get, basically we need to put n equals to 1 now. So earlier we put n equals 0, now putting n equals to 1. So we know that this should be equal to 5. And now 3 raised to power 1 is actually 3. So 3 C1 will have a coefficient of 3. And minus 1 raised to power minus 1 is minus 1. So C2 will have a coefficient of minus 1. So this will be actually minus C2. And this will be equal to 5. So these are the two equations which we obtain. C1 plus C2 is 1 and 3C1 minus C2 is 5. So just solving these two equations, uh, like it's easy to solve. Like we have a plus C2 in first and minus C2 in second, so we can just easily add them up. So we'll obtain 4 times C1 will be equal to 6. So we'll get C1 equal to 3 by 2. And putting in 3 by 2 here, we'll get C2 equal to minus half. So I'll just write down the solution. Solving for C1 and C2 using the above equation, we get C1 equals to 3 by 2 and C2 equals to minus half. Okay, so what this means is that so our actual solution will be just putting, so the general solution for this an is equals to C1 3 to the power n plus C2 minus 1 to the power n will be, we would just put C1 as 3 by 2 and C2 as minus half. So thus an will be nothing but C1 3 to the power n plus C2 minus 1 to the power n. And now putting in C1 and C2, values of C1 and C2, we get an is equals to, an was earlier of the form this, right? So an was earlier of this form, this C1 3 to the power n plus C2 minus 1 to the power n. And now putting in C1 and C2, we'll just get this thing. So yeah. So this is our final answer. I'll just bold it. Although it's not formatted very good, but I guess you can easily understand that 3 to the power n has a coefficient of 3 by 2 and minus 1 to the power n has a coefficient of minus half. So it can be easily seen that this actually corresponds to this option B, although it does not seem like it, but yeah. So this 3 can be taken in with this 3 to the power n to make it 3 to the power n plus 1. And then this minus 1 and minus 1 to the power n will make it minus 1 to the power n plus 1. And then whole has a denominator of 2. So that's why option B is equivalent to this. So option B is the correct option here. So I hope I made sense here. So if there are any doubts, you can again like ask me in chat or anything. Otherwise, I'll just proceed to the fifth question. Okay, so fifth is also not that difficult of a question. It's a simple one. So fifth question says that consider the set P of points in a coordinate system with n coordinate axes of the form plus minus 1 plus minus 1 plus minus 1 n times. So we are sort of in an n dimensional space, and the and all the coordinates can only take the value of either plus 1 or minus 1. It can't take any other value than plus 1 or minus 1. So how many points can be there in this space? Like this is not related to this question, but I'm just asking. So would anyone like to answer? So if every coordinate can take plus minus 1 value and there are n coordinates, so how many possible points can be there in this space? NP, what is NP, Priya? Oh, you're saying what is P here? Uh, I'm not asking related to this question right now. I'm just asking like if we are just given uh plus minus, like if we are given a space which has points of the form plus minus 1 plus minus 1 plus minus 1. So how many possible points can be there in this space? So what I am so actually there will be sort of something like 2 to the power n possible points. That's what I was looking for. So because note that every point will have either plus 1 or minus 1 in its ith coordinate, right? And there are n coordinates. So basically, uh, every every coordinate, like every axis will have two choices. Like in for every point, like every dimension will have two choices, either have plus 1 or have minus 1. And there are like n dimensions, and each dimension has two choices. So first dimension has two choices, second dimension has two choices, third dimension has two choices, and till nth dimension has two choices. So the total number of possible points will be 2 times 2 times 2 times 2 up to n. So it will be something like 2 to the power n points. Okay, so it's clear, nice. So yeah, although this was not related to this question, I just wanted to discuss this. So in a space where points can be only plus minus 1, then also there can be like 2 to the power n possible points. Yeah. So now let's just consider one point out of this space. So this is the set of points which were given to us. And now the problem is saying, let's just consider some point P in this space. And the problem is asking how many points apart from P must be chosen from the set capital P. So capital P is the this set of size 2 to the power n. Like capital P was the set of all possible points of this type. So capital P was actually the 2 to the power n size set. And now how many points from this set capital P should I choose so that uh, from along with two other points from the chosen set, we form an isosceles triangle with the point P. So I believe this problem is easier to solve, but it's a bit harder to understand. So uh, I want you guys to spend a minute looking at this problem and try to understand what it's asking. So just we are given a lot of points like these 2 to the power n points, which have every coordinate as plus minus 1, plus minus 1, plus minus 1. Basically every dimension as plus minus 1. And now we are also given some arbitrary point out of these set. And now we want to choose some more points so that we can ensure that from those more points which we have chosen, there will exist 2 points which along with the initial point small p will form an isosceles triangle. And what's an isosceles triangle? A triangle in which two sides are equal. So does the question make sense first of all? Uh, Basically, we are given 1 point in the problem, and now it's the problem is asking how many more points will we need to choose so that along with the given point, will we can always form an isosceles triangle. This is what the problem is asking. So if the problem is not clear, like you can ask me in chat if you can tell me in chat if it's not clear. Otherwise, I'll just assume it's clear to everyone. So then let's just proceed to like how to solve this question. So uh, so isosceles triangle is just a triangle in which two sides are equal, right? And it's given to us that the two equal sides should be incident on P. So let's just say the points P1 and P2. Maybe let's just say points P1 and P2 are the point. Let's just say P1 and P2 are the points which eventually form. Like this is I'm giving sort of an intuition here. Like we don't know what P1 and P2 will be because we can only choose a set. But what I'm just trying to say is let's just say P1 and P2 are the points which eventually form an isosceles triangle with P. So let's just say P1 and P2 are the points. And as the equal sides should be incident on the point P itself. So what this means is that uh, distance between P and P1, distance between P and P1 will be equal to distance between P and P2. This is definition of isosceles triangle, right? That length and length is nothing but distance, the distance between points. So that distance between the points P and P1 will be equal to distance between the points P and P2. So if this condition is satisfied, like if we can find 2 points P1 and P2 such that this condition is satisfied. So then we can say we'll have an isosceles triangle. So if the distance condition. So if we choose some points such that for 2 points, for at least 2 points, the distance condition is satisfied, then the triangle will be isosceles. Right. So now problem reduces essentially to uh, choosing some points such that there exists 2 points such that distance between P and P1 is equal to distance between P and P2. Problem reduces to choosing a set of points from P such that always exists at least 2 points P1 and P2 such that distance between P1 and P2 is this. Distance between P and P2 is equal to distance between P and. Okay. Yeah. So this is essentially what we need to find out, right? And now actually what we can see is, so note that in an n coordinate system, like here, this is an n coordinate system, right? Because there are n different dimensions. So how do we find distance between 2 points? So we find it by distance formula, right? And distance formula is nothing but let's say the distance between the square of distance between first dimensions. So like let's just say we were just given 2 points x1 y1, and like the dimension like n was equal to 2, and we were given points as x1 y1 and x2 y2. Then the distance between those 2 points will be nothing but x2 minus x1 whole squared plus y2 minus y1 whole squared, right? And the square root of that essentially. So now this distance is just extended to n dimensions, and instead of just taking the squares of differences in 2 dimensions, we just take it in n dimensions. And that's how we calculate the distance between any 2 points, right? So now what my claim here is that since the points like the x1, x2, x3 values can only be +1 or -1, so note that let's just say in point P, uh, like I'll just try to give an intuition first without typing. So let's just say in my given point P, uh, the ith dimension had a value of 1, right? The point P's ith coordinate was 1. So if in another coordinate, uh, if for another point P prime, the ith coordinate is 1, then this then the distance between these two, then the ith dimension will be 0, because 1 minus 1 whole squared will be 0. And if it is -1, then it will be something like 1 minus of -1, which will be 2 squared. So what I'm sort of trying to say here is that mm, uh, now for any point P prime, if P if P prime differs from P at the ith coordinate, or maybe I should try to uh, claim it in a different manner, write the statement in a different manner. So this is what we already know, right? The distance thing. Now what I'm trying to say here is that for any 2 points, or maybe let's say for any 2 points, P1 and P2, maybe let's just define. So this is the Euclidean distance, right? This distance which we want to be equal. So what I'm trying to claim here is that, so if we are given a point P and P1 is a point such that, let's say P1 and P differ at like let's say X number of coordinates. Like let's just say P and P1 have the same first coordinate, have the same second coordinate, have the same third coordinate, but they don't have, let's say, same fourth coordinate, they have different fifth coordinate, they have different seventh coordinate, and so on. So the number of coordinates, the number of dimensions in which they differ, let's just say that is X. So what I'm trying to say here is, so if they differ in X dimensions, and if there is another point which differs from P in X dimensions, then for both of those points, the distance from P will be equal. Maybe I don't have a figure to explain it, so I should uh, write it down as a mathematical claim. Uh, so my claim is something like this. Uh, for any point P prime in capital P, if P and P prime differ at X coordinates, that is P and P prime have different values at X number of dimensions. So like if P has some +1 in one dimension, P prime has -1. Similarly, if P has -1, P prime has +1. And this happens at, let's say, X number of dimensions, like 10 dimensions. This can happen in 10 dimensions, this can happen in 20 dimensions, or whatever. Then what I can say is, then the distance between P and P prime is equals to 2x. So this is my claim that if P and P prime differ at X coordinates, so maybe let's just take an example of maybe just 2 dimensions. For now, let's just take 2 dimensions. So consider one point, the P point as +1 comma +1, and P prime as -1 comma -1. So example here is uh, take P as 1 comma 1 and P prime as -1 comma -1. Then we know that here basically they are differing at first coordinate also. Here first coordinate is different for P and P prime. Second coordinate is also different. So X is equals to 2 here. So this implies that X equals to 2 here. And what's the distance between P and P prime here? By distance formula, it will be 1 minus of -1 whole squared. So it will be something like 2 squared, which will be like, this will be something like 2 squared plus 2 squared, which will be, yeah, this should be actually 2 square root x. So this will be something like so the distance between these 2 points P and P prime, if they are these -1 - 1 and +1 + 1, will be something like square root of 2 squared plus 2 squared, which will be something like square root of 8, which will be 2 root 2. Uh, Also, distance between P and P prime is equals to 2 square root 2. Like it is easy to see using distance formula that distance will be 2 root 2. And this 2 root 2 is nothing but actually this value only, 2 square root of x, as we see x was also 2. So this is actually equal to 2 square root x. Yeah. So, and how can you, so this was just an example, like what I wanted to explain by this claim. So we'll obviously need to prove this claim also, but this claim, what I'm trying to say is this claim is very easy to show. You can maybe try to show it yourselves also. So its proof is very simple. It can be done using proof of the above claim is simple and is simple can be done just by applying distance formula. Just by applying the distance formula. So this is something you should try you should try yourself. Oh, so yeah. So basically, we know that if two points differ at x coordinates, then their distance is actually 2 root x, right? So for points P1 and P2 to be equidistant from P, so P1 and P2 should be equidistant from P, right? So both P1 and P2 should act. So note that if 2 points differ at x coordinates, then their distance is 2 root x, right? So if P and P1 have some distance, so if P and P1 differ at x coordinates, then their distance will be 2 root x. If P and P2 differ at y coordinates, then their distance will be 2 root y. But we want their distances to be equal. This can only happen if 2 root x equal to 2 root y, which will mean that x equal to y. And what was x and y? So basically, if P1 and P2 differ from P in equal number of coordinates, like not exactly the same coordinates, like it can happen that P and P1 differ at first dimension and second dimension, and P and P2 differ at third dimension and fourth dimension. But the total count of dimensions should be same at which they differ. So I hope you guys understand. This is a bit tricky, but uh, this is a bit tricky to explain without any figures or like without any tablet or anything, but I hope I'm making a bit of sense here. So, so both P1 and P2 should differ from P at same number of coordinates. So note here that I have written this number of coordinates, not the exact coordinates, but the number of coordinates at which they differ should be same. Yeah. So the number of coordinates at which P1 and P2 differ from P should be same. So let's just say for the sake of simplicity that P was all ones. Then P1 is something which should like if P1 differs at two coordinates, then P2 should also differ at two coordinates. So P2 should be -1 at exactly two coordinates, and P1 should be -1 at exactly two coordinates. That's something which I'm trying to say. If P was all ones and P1 was -1 at two coordinates and +1 everywhere, then they differ at two coordinates, right? Similarly, we can define for P2 also. So now what I'm trying to say here is that, so again, here I'll define something like a type of a point. Type of a point. Like I defined earlier the type of a person, type of a guest in the first question. Similarly, I'll define type of a point. And what will be type of a point? Uh, the number of the number of coordinates at which the point differs from P. So basically type of a point will be a number associated with that point, which will just be number of coordinates at which the point differ from P. We are given this point P already in the question. So from this point, at the number of coordinates at which the new point differs, it will be the type of that point. So is this definition clear? Like, uh, how many total possible types can be there for a point? Like how many possible types are there if there are n dimensions? Would someone like to guess? Okay, maybe I should answer it myself. So yeah. So there can only be n possible types, right? Because we are just interested in number of coordinates at which point differs from the point P. And there are in total only n coordinates, right? So actually there will be n plus one types. So there are total n coordinates. So the 2 points can only differ at either like if the 2 points are exactly similar, exactly the same points, then basically uh, they differ at zero coordinates. If they differ at one coordinate, then they'll be of type one. They can differ at two coordinates, and maximum they can differ it as it are n coordinates because there are maximum n coordinates given in the question only, right? So thus there are only n plus one possible types. And also, what we showed here was that for any 2 points P1 and P2 to be equidistant, they should differ from P at the same number of coordinates, which essentially means that they should be of the same type. So basically, if 2 points are of the same type, then they form an isosceles triangle. So this is something which just follows from the previous discussions, that if 2 points are of the same type, then they form an isosceles triangle with P, right? And there are n plus one possible types, but we only need the points which are uh, distinct from P, right? We don't, in the question it was already said that we can only choose points which are not P, like which are distinct from P, apart from P. So there are n plus one possible types, but one of these types is the type which does not differ from P, where number of coordinates at which point differs is zero. So that will be the point P itself. Like P is exactly the same as P. So, but we only want the types which are actually different from P. So even though there are n plus one possible types, uh, the types which are of interest to us are only n, because the n plus one type is just the point P itself, and we are not allowed to choose P anyways. But the only n relevant types for us as the type 0 is just the point P itself. So there are only n relevant types. So if 2 points are of the same type, then they form an isosceles triangle with P. Right? It's given to us that if two, so like this is what we have concluded till now, that if 2 points are of the same type, then they form an isosceles triangle of P. And there are these n relevant types, right? So how many points will we need to choose to ensure that at least one type has 2 points? Like something like a previous discussion which we had, that here we needed at least two guests to be comfortable with each other, and we said that we should invite 31 guests because there were 30 types of guests. Similarly, here we need to select, we are given n types, and we need to select some points such that at least 2 points become the same type. So we'll sort of need to select n plus 1 points here. Like we did there, that there were 30 types, so invited 31 guests. Similarly, here there are n relevant types, so we'll be having n plus uh, 1 points. So we'll be choosing n plus 1 points. So if 2 points are the same type, then they form an isosceles triangle with P. So we'll need at least n plus 1 points. So as done in question 1, we'll need at least n plus 1 points to ensure that 2 points are of the to ensure that at least 2 points are of the same type, and hence form an isosceles triangle with P. So yeah, so this is the actual answer, the n plus 1. So I believe this last question may have been a bit confusing. So I would recommend you guys to, maybe if you guys have not properly understood this, to watch this recording again, as this will be uploaded on YouTube anyways, or maybe also go through these notes again. Because I believe like if you read it again 1 or 2 times, then you'll be able to understand. Because there is nothing new which I've done. There was just this concept of differing number of points and the distance formula and stuff. But other than that, everything was similar to question 1 only. So yeah, just working it out yourself, you'll be able to do this, I'm pretty sure. So the correct answer is actually n plus 1 here, which is this option B. Hence, option B is correct. Okay, so this was it from my side. So yeah, I only want to discuss these 5 questions. So yeah, these have been discussed, although we have overshot by like 2-3 minutes from our allotted time. So like just as an ending note, for like in quick 2-3 minutes, if you have any doubts, maybe you can ask me and I'll try to clear it for this whole stage. And I'll try to clear it, or yeah. So if any of you has any doubts, Priya or Janvi, maybe we can discuss those in like 2-3 minutes. And like if you don't have, then maybe we can sort of close this session. Okay, so you don't have any doubts. Nice. So yeah, just again a reminder. So yeah, I believe last question was a bit, may have been a bit hazy for you guys, but I'll just encourage you guys to just go through this again in the recording and just look at this solution again. And I'm pretty sure you guys will be able to understand it. So yeah. So then I guess this is it for the day. I'll just stop sharing my screen. So thanks for attending the session, guys. So hopefully we'll see you guys next week also. So till then, bye bye and yeah, good luck for the submission tomorrow.